Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Scientists in New Zealand and Australia working at the level of atoms created something unexpected: tiny metallic snowflakes. Why is that significant? Because coaxing individual atoms to cooperate in desired ways is leading to a revolution in engineering and technology via nanomaterials, and creating snowflakes is cool. Nanoscale structures, a nanometer is 1/1000th of a meter, can aid electronic manufacturing, make materials stronger yet lighter, or aid environmental cleanups by binding to toxins. To create metallic nanocrystals, New Zealand and Australian scientists have been experimenting with gallium, a soft, silvery metal which is used in semiconductors and, unusually, liquefies at just above room temperature. Their results were just reported in the journal Science. Professor Nicola Gaston and research fellow Dr. Steph Lambie, both of Waipapa Taumata Rao, University of Auckland, and Dr. Krista Steenbergen of Te Haranga Waka, Victoria University of Wellington, collaborated with colleagues in Australia led by Professor Courash Kalantar Zadeh at the University of Nae. The Australian team worked in the lab with nickel, copper, zinc, tin, platinum, bismuth, silver and aluminium, growing metal crystals in a liquid solvent of gallium. Metals were dissolved in gallium at high temperatures. Once cooled, the metallic crystals emerged while the gallium remained liquid. The New Zealand team, part of the McDermott Institute for Advanced Materials and Nanotechnology, a national centre of research excellence, carried out simulations of molecular dynamics to explain why differently shaped crystals emerge from different metals. The government's Marsden Fund supported the research. What we are learning is that the structure of the liquid gallium is very important, says Gaston. That's novel because we usually think of liquids as lacking structure or being only randomly structured. Interactions between the atomistic structures of the different metals and the liquid gallium cause differently shaped crystals to emerge, the scientists showed. The crystals included cubes, rods, hexagonal plates and the zinc snowflake shapes. The six-branched symmetry of zinc, with each atom surrounded by six neighbors at equivalent distances, accounts for the snowflake design. In contrast to top-down approaches to forming nanostructure, by cutting away material, this bottom-up approaches relies on atoms self-assembling, says Gaston. This is how nature makes nanoparticles, and is both less wasteful and much more precise than top-down methods. She says the research has opened up a new, unexplored pathway for metallic nanostructures. There's also something very cool in creating a metallic snowflake. Make a difference. Sponsored opportunity StorySource, materials provided by University of Auckland. Note: content may be edited for style and length. Journal reference: Shuhada A. Idris Saidi, Janbo Tang, Stephanie Lambie, Jalo Han, Mohamed Mayaz, Mohammed B. Gassemian, François-Marie Aliou, Shengshang Kai, Pramod Koshi, Payman Mostagimi, Krista G. Steenbergen, Amanda S. Barnard, Torben Danicki, Nicola Gaston, Courash Kalantar Zadeh. Liquid metal synthesis solvents for metallic crystals. Science, 2022, 378, 6624, 1118 doi, 10. 1126, Science. ABM 2731. Cite this page, University of Auckland. Scientists mimic nature to make nanoparticle metallic snowflakes. Scientists in New Zealand and Australia working at the level of atoms created something unexpected, tiny metallic snowflakes. Science Daily. Science Daily, the 9th of December 2022. ift.tt/huvik7g. University of Auckland, 2022, December 9th. Scientists mimic nature to make nanoparticle metallic snowflakes. Scientists in New Zealand and Australia working at the level of atoms created something unexpected, tiny metallic snowflakes. Science Daily. Retrieved December 9, 2022 from ift.tt/huvik7g University of Auckland. Scientists mimic nature to make nanoparticle metallic snowflakes. Scientists in New Zealand and Australia working at the level of atoms created something unexpected, tiny metallic snowflakes. Science Daily. https://ift.tt/huvik7g. Access December 9, 2022. Thanks for watching. Please subscribe my channel for more videos.